Hello everybody. So today I will talk about calculus. The topic today is about double integrals. So now I will show you how to answer. The following integration problem can be rewritten as one set of double integrals. Make this conversion to a single set of double integrals and also evaluate it. So now I will show you how to answer. If we look carefully about this one, we just concentrate about dy and dx, similar for this one. About the first one, we have dy, so y in this situation is greater than negative s and smaller than the square root of 4 minus s squared. About dx, s is from negative of the square root of number 2 and number 0. And the second one, we do the same. Y is greater than or equals to number 0 and smaller than or equals to the square root of 4 minus s squared. dx, that is from 0 to number 2. Now, we need to concentrate about this function because we have the same in here. So, we have y equals to the square root of 4 minus s squared. Now we put the power 2 for the both sides to cancel about the square root. So this one, we have 4 minus s squared. So I will put this one go to the left. And we see that this is about the circle with the center 0, 0 and the radius is about number 2. So we need to draw the circles in here. Now, we know that the circle is about 0, 0, so this is about the center in here. The radius is about number 2, so we have number 2 in here, positive number 2 in here, this one negative number 2, this one negative number 2. Now, if we look on the bounds, we know that from 0 to number 2, y is greater than number 0 and smaller than or equals to the square root of 4 minus s squared. We know that this is about the positive. The positive that should be in here. So, from 0 to number 2, from 0 to number 2 in here, for s, we know that y is greater than number 0. This one, that is about y equals to number 0. This one, that is about y equals to the square root of 4 minus s squared. So the area from 0 to number 2, that is about this one. So the next one, from 0 to the negative of the square root of number 2, we see that y is greater than or equals to negative of s. So we know that the graph of y y equals to negative s. That should be like this. So we know that y is greater than or equal to negative s, so they should be in here and smaller than this one in here. The intersection between the line and the circle you create about negative the square root of number 2 in here. So the area of this one that should be in here. Now we can use about the next one, that is about polar coordinates. Now I will put about s equals to r cosine theta, y equals to r sine theta, dy dx we change by r dr d theta. Now we look carefully about this one. So we want to combine two double integrals together, so we can use about polar coordinates. We see that we have same y, we have same dy dx. Now we combine two things together. So about y we change by r sine theta, dy dx we change by r dr d theta. Now the first one, that is about dr that is about the radius of circle. So we know that the radius is about number 2, so the integration should be about from 0 to number 2. About d theta, we know that we start in here and we stop in here. So this one that should be about 0. This location here, we know that this one is about b over 4. This one that is about b over 2. So we sum two numbers together. We have 3b over 4. So the integration in here from 0 to 3b over 4. And now we need to calculate about this integration. So we have r and r, we have r squared. The integration of r squared, we have r to the power of 3 over 3, and we put the bounds from 0 to number 2, and we have sine theta d theta. So I will put number 2 gone here, number 0 gone here. We calculate about this one, and we have 8 over 3. And we have the integration from 0 to 3b over 4. And now I will put this one gone here. The integration of sine theta we have negative cosine theta. So I will put this one cone here and this one cone here. So we have negative cosine 3b over 4 plus cosine of number 0, and we have 8 plus number 4 with the square root of number 2 over number 3, and this is the final answer. This is the end. Thank you for watching.